Hello everyone. I'm Shan Khanna, an MCA student at Chanakya University, and I'm presenting this work under the guidance of JBC Masar. This research explores how we can use machine learning models to improve heart attack prediction and early diagnosis. Our project investigates how these models, machine learning algorithms, KNN, naive Bayes, and decision tree can predict cardiovascular diseases. We used a dataset with over 70,000 patient records to train and compare these models. The goal is to detect risk early and support clinical decision making. Dataset overview and pre-processing. The dataset includes features like age, gender, height, weight, blood pressure, cholesterol, glucose, lifestyle, and medical indicators. Pre-processing steps included converting age from days to years, calculating BMI using height and weight, removing outliers using IQR, normalizing continuous values, and coding categorical values. So we have exploratory data analysis. We performed correlation analysis to identify which features strongly impact heart health. The key findings are age, cholesterol, and systolic blood pressure have high correlation with cardiovascular risk. These insights help us prioritize which features to focus on during model training. KNN model. The K nearest neighbors classifies a new patient based on the K closest patients in the data set. It uses distance metrics to find neighbors. We optimize the value of K using grid search CV. It is simple and effective, especially for smaller data sets. Naive Bayes model. Naive Bayes is a probabilistic model that assumes each feature contributes independently to the outcome based on Bayes theorem. It is fast and works well even with large or high dimensional data, often used in text classification, but also performs well here. Decision tree model. A decision tree is like a flowchart that splits data based on feature values. It is interpretable and transparent, showing which variables matter most, easy to understand and visualize, handles both numerical and categorical data as well. So we have model evaluation metrics. We have evaluated each model using accuracy, precision, recall, and F1 score. So KNN has accuracy of 0.86, precision of 0.81, recall a value of 0.79, and F1 score value of 0.80. Naive Bayes have accuracy of 0.88, precision of 0.84, recall of 0.83, F1 score of 0.83. Decision tree has accuracy of 0.91, precision of 0.89, recall of 0.86, F1 score of 0.87. Decision tree here performs the best overall. So decision tree is the best model here. So we have confusion matrix of KNN model. This matrix helps us understand how well the model predicts. True positives, correctly identified cases, and false negatives are missed heart attack cases. In KNN, we had moderate false negatives, meaning some risk cases might be missed. So we have a Naive Bayes model of confusion matrix. Naive Bayes shows improved performance, better precision and recall, fewer false negatives compared to KNN, faster prediction time is still, there is room to reduce false negatives further. And the last one is decision tree. So decision tree shows the best confusion metrics, least number of false negatives, better at detecting actual cases. This makes it more suitable for clinical use where missing a case can be dangerous. So we have decision tree feature importance. So what is this? The decision tree highlights age as the most important predictor, followed by systolic blood pressure and cholesterol. This helps doctors focus on the most critical features and increases trust in the model. So here is the summary of all models. Decision tree has highest accuracy, easy to interpret, no need for normalization. So it is the best. Naive Bayes. Naive Bayes is fast and efficient, works well with large data. So it is a moderate, so it is not best, but it is a better model to use in the data set. So we have last model is KNN. It is simple and non-parametric, good for small data sets. Each model has its strengths depending on the application. So we can't say decision tree is the best, Naive Bayes is the best, KNN is the best. Everyone has its own importance and features. So conclusion and future work. So to improve the system, add more patient categories, build real-time dashboards for doctors, try and assemble models for better performance. This will improve early diagnosis and potentially save lives. Thank you.
Hello everyone, my name is Karthi. We are going to look the heart attack detection is a classification type. My teammate Sean explained the theory part. Now we are going to look the implementation part. At first we are importing the required libraries. First pandas and numpy. Numpy is nothing but if we are using numerical data means numpy we need to use, and we need to import the libraries data visualization. It's a matplotlib dot pyplot and a cbond, and we need to import some modeling and validation. These are all the train test split, standard scalar, and k neighbor classifier, classification report, and confusion matrix. These are all from sklearn model. We are importing from there, and at first we are reading the data from the CSV file. In the CSV file, the records are not properly set. So we are separating that with a semicolon. At first, we are print the column, what column in there, and what are the column the data set occurs. The columns are ID, age, gender, height, like that. The columns are there. Looking the head means it will print the first 5 data, and then we are going to tail means it will print the last 5 data, and we are checking the how much the data in the data set in every. For that we need to use df.count. Df means data frame. In everything in every column there are 70,000 data is there. Next, we are going to check the any data values are null or not. God grace, here no null values appear. If null values is appear means we going to look at that. Remove that null values. And next we are checking the info, the data type of everything here, and it will give the how many data types in the integer and how many data types in the float value. Now we don't want the id column, so we are removing the ID column. For that we are using drop command. Next, in the CSV file, the age columns are in the days format, so we are going to change that into years format. For that we are using this command. Now we are going to print the outlier of in which age the people get heart attack most. Here you can see uh, blue color means no disease, orange color means disease. At the age of 59, most of the people dying from heart attack according to the data. And next we are going to print the correlation of the data. Here the correlation is we can differentiate into three types: positive correlation, negative correlation, and no correlation. Zero means no correlation, above zero means positive correlation, and negative below zero means negative correlation. Here 0.5 is there. No, this is good correlation. Height and weight we can set it into one frame. For that we are going to use this. This is the BMI formula. BMI formula is uh, weight in kg, na weight divided by height by 100 and power 2, and we are going to describe that, print that values what in there. Now we are going to filter the data according to the research paper. They gave the condition. According to that we are going to filter the data. First, APHI is greater than or equal to 90 and it should be less than 170. Like that, APLO is greater than or equal to 65 and less than or equal to 105. Height is above 140 and less than are equal to 210. Weight also like that, above 40 and less than or equal to 160. That formula we used again here. And now we are going to plot for the features are age, APHI, APLO and height and weight. For that we are using box plot. X equal to futures. Futures are this, and Y equal to value of the futures. Here you can see this dot. This dot is the outlier, and blue color is 0. 0 means no disease. Orange means disease. Here at the age of 25 to 35, the most of the people are dying by heart attack. Now we are going to print the filtered data. These are the filter. According to this condition is there now. According to this we are filter the data. Now we are going to do the implementation of formula. There are three formulas there: Euclidean, Manhattan, and Minkowski. We are differentiate the values of x is features are this, and y is cardio. Going to differentiate this: x is featured and y is cardio. We are going to split the training different and test is different. Here we are going to take the test size is equal to 20%. 0.2 means 20%. Balance 80% is training set. And the random stat is 42. And here we are using stratify. Why we are using stratify means, if we accidentally don't apply stratify means, the most training set training cardio equal to 0, it would be set into training, and the cardio equal to 1 should be set into test data. Now we are scaling the, here the fit transform. Here the fit, it will calculate the mean and standard deviation only on training data, and this transform apply the same scaling for everything. Here we are using Euclidean, Manhattan, Minkowski. If p equal to 2, here p equal to 1 and p equal to 3. Here we are using k nearest neighbor formula, we are declaring k equal to 3 here. You can see for every test point, it finds the 3 closest 3 training point and assign the most frequent label among them. Here we can see Euclidean, Manhattan and Minkowski. The accuracy rate is 65% here, same as Manhattan and Minkowski. In the research paper we got, in there they applied 70% training and 30% testing. Now we are extended that into 80% training and 20% training. First we are doing the k nearest neighbor and then decision tree classifier and name based classifier. First k nearest neighbor, we are assigned the value equal to 3. Then we are giving the implementation. The accuracy are 0.65. 65% are no disease. And we are going to decision tree. While using decision tree, the accuracy will come at 62%. And if we go jump into naive based classifier means the accuracy came at 0.70 means 70%. Same as we are going to use 90% training and 10% testing. Here we declared 0.1% for test size and split the training and test data. First we are going to k nearest neighbor classifier. Here the accuracy came at 0.65 and in the decision tree classifier the accuracy came at 0.63. See, 63 means 63% accuracy. Here neighbors classifier in 71% it came. If we give the 80% training and 10% 20% test means it gave 70%. If you give 90% training and 10% test means it give 71%. Now we are going to look at k-fold cross validation. For that we need to import stratified k-fold and cross val predict from sklearn. This allow we are already imported. For the k-fold cross validation, we need to do this. It will split the 3 equal size fold. Divide the data into 3 equal size fold and stratified means it ensures each fold maintain the same proportion of each class and it shuffles true means it's randomize the data before the splitting. Here for cross validation prediction, here it split the data into 3 folds now. It trains the 2 data and it left the 1 data out. It will repeat the steps until every point has been tested once. Here you can see the accuracy came at 0.68. It means 68%. Now we are going to look at the confusion matrix. For confusion matrix also we need to give k-fold. We are going to see k nearest neighbor and decision tree and naive Bayes. For everything we are going to see confusion matrix. For k nearest neighbor matrix, it give for no disease and no disease, it give true negative, it is false positive, this is false negative, this is true positive. Which means true negative means it correctly predicts the no disease. FP means it correctly predicts the disease but it's healthy for us. It incorrectly predicted the disease but they are healthy. False negative means it missed the actual disease. This true positive correctly predicts the disease. For decision tree, it is TP. TP means true positive. This is a false positive. FN false negative. This is true positive. Here 21,335 is a true negative. Here slightly compared to k nearest neighbor, slightly more false negative. It misses more diseased patient. and slightly fewer true positives. Here this is true negative, this is false positive, this is true false negative, and this is true positive. Is very conservative in predicting has disease. Less false positive. See, you can see. But this come at cost more F1, false negative, miss more actual patients. Neighbors has high specificity and good at identifying healthy, but lower sensitivity. It misses more disease now. Among the three matrix, if we look into which is best means, if we care about detecting diseasing means like minimizing the false negative, it KNN is best. And if you care about avoiding the false alarm, minimizing the FP means uh, name base is best. Like that, we need to look. Uh, we saw the every implementation we did in the research paper. Thank you, everyone.